Hi, I'm Sterling Finn. I'm a second-year software engineer at Waterloo University in Waterloo, Ontario. And I'm here in Ottawa, Canada, at Pelyco Systems. Pelyco Systems is a software consulting company based in Ottawa and in Silicon Valley. They work with companies to improve their form of software, mostly pertaining to Excel and supply chain. The ExNFlex company is now working with Andrew Goodwin of Northbridge Technology and Pelyco Systems to improve the software on the ExNFlex, which is a physical therapy bike for people who are disabled, often paraplegics. Studies show that exercise, even in extremities with little to no movement, have great health benefits. So the software on those machines are critical. And this summer I worked to improve the software. Let's go check it out. So this is the working ExNFlex system. Basically, it turns your legs at various speeds, low, medium, and high. Also, it goes in reverse. Pretty cool. Here is the controller. Here's the 7-segment display. You can change the mode between time, trip, total distance, and BIOF, which measures the resistance of the user's legs. This is the ExNFlex test jig, built by Andrew of the ExNFlex company for me to work on this summer. This is the old chip. It was built in the 1990s and it's too old. This is the old user interface with 6 buttons to control the motor and the console output, which back in the 90s was just this 7-segment display. This is a windshield wiper motor, which is used to power the ExNFlex, and on the new machine will remain because it's very reliable. This is the arm. It turns, and it turns the people's legs. This is our attachment. It's a magnetic sensor which detects a full rotation of the motor, and using that calculates the period of the arm, which then does calculations to measure rotations per minute, speed, and distance. Now, this is the new chip that we are working with. It is an Atmel SAM E70 Explained, and the chip itself is an ARM microcontroller. The output and input all comes on this extension. On this chip, we are running FreeTOS, which is a real-time operating system that serves real-time devices like the ExNFlex, where processes need to occur under fixed time constraints. So let's get in there and check it out in action. First, we power it on. In the final product, there will be support for both the forward and reverse direction, but currently the hardware only supports forward. But there is a motor signal being output to power the reverse. This is an example of it. So now that it's on forward, you can change the speed. There's low, medium, and high. There are 3 output modes. The first one is total time, shown here. So the motor has been running for about 27 seconds at this speed. The second one is total distance, which can be displayed in miles, kilometers, and meters. The final mode is speed, which can be displayed in meters per second, miles per hour, and kilometers per hour. Another important factor in a system like this is safety. So I added functionality to stop the motor if something is blocking the arm. Watch this. If I put my book under the arm and stop the arm, after about 5 seconds, the motor will turn off. And then you can just turn it right back on and do it again. Just like that. So that's the ExNFlex, the project I worked on for my first co-op, summer 2018. After I leave, my project will be taken over by one of my co-workers to be improved even more, mainly by adding a Bluetooth module and adding an LCD screen with touchscreen functionality.